Okay, so let's go ahead and get started with the second page of our geometry assignment. So, dealing with exponents, our question is 7 radical 600. Now, we're just going to look at our 600 right now. We know this one's a little bit almost a given. We know that because it is 600, we have a perfect square in here. That is 100. So we're going to go ahead and move this down. That's going to give us the square root of 100. And then we're left with the square root of 6. Now, there is no perfect square in 6, so we're just going to leave that there. We know 100, 10 times 10 is 100. So we have 10. And as you know, as I said from before, when I have a number here, this is not a math rule, but this is just my sign of saying we're going to multiply these two numbers. So we have this 7 on the outside times this 10 on the inside. That's going to give us 70 and then radical 6. So our answer is 70 radical 6 for that. Our next question is Our next question is 5 radical 45. Now, if you remember, back when we went to question 7, our question was radical 45. So we're going to use the exact same answer to find this new one. So everything's still the same. We're going to take the square root of 5 out and the square root of 9. The square root, 5 has no perfect square in it, so we're going to keep that the way it is. 9 has the square root of 3, so it's going to be 3 square root of 5. We still have this 5 on the outside. We're going to multiply it with this 3, and that answer is going to be 15 radical 5. We did not have 180. Okay, so our next question is 5 radical 180. So for this one, by just looking at 180 without any prior math knowledge, we can tell there's going to at least be a 4 in there. So we're going to take the square root of 4 out, which we know is 2. And then 180 divided by 4 is 45. The square root of 45. And from previous knowledge, as we did before, the square root of 45 is 3 radical 5. So we're going to multiply this 5 times 2 and this 2 times 3. So we're going to get 30 radical 5 as our answer. Radical 5. Our next question is 3 radical 405. Okay, now 405, by just looking at it, you would not know the perfect squares that are in 405. So with all else fails, we know that there's a 5 in there. And we know from previous questions that once we get to the 5, there's no more perfect squares in there. So I'm going to just go here and do the square root of 5. Now we're going to take 405 divided by 5. And our answer is going to be 81. Square root of 81. The square root of 81 is 9. 9 times this 3 is 27. Radical 5. There's our answer. Our next question is 2 radical 36. Okay? We know at least up to 10. So you should know 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So we're going to, because we know this common math knowledge, we're just going to pull this 6 down. multiply it by this 2, and our answer is 12. That's it. That's the answer right then and there. Our next question is 9 radical 125. Radical 125. Now, we know that there's at least 25 in there. We know how to count by 25. We at least know how to count by 25, so we're going to pull 25 out. The square root of 25. And then we have this radical, the square root of 5 as well. Okay? So this we know can be reduced any further. The square root of 25 is 5. So we have 5 by this 9 is going to be 45 with the square root of 5. So our answer is going to be 45 radical 5. Next we have 8 radical 27. Okay, now we know that 27 is not a perfect square, but it has a perfect square. We know that it has a 9 and a 3. 9 times 3 is 27. So we're going to go ahead and pull the square root of 9 times the square root of 3. We know this is going to be 3. Multiply this 8 by this 3. You get 24 radical 3. Is our answer. Now here's where we have a little bit of fun. These next, really the next, so 20, 22, and 23 are all pretty similar because they deal with numbers in the thousands that are not easily recognizable as having multiple perfect squares in them, unless you just know unless you can pick up on patterns easily. They're not easily recognizable perfect squares. Okay, so we have 12 the square root of 1,764. Now this is a complex number. This is a perfect square in and of itself. But without prior knowledge, we're going to work it piece by piece all the way down so we can see where we're coming from. So we know that there's at least a 4 in there. So we're going to pull 4 out. 4, and we know that's going to equal a 2 later on. Now, 1,764 divided by 4 is 441. Now, we can just do the square root of 441 on your calculator. Well, you really could have did the square root of this number, but if you wanted to work it all the way down to see especially if your teacher wants you to know how you got there and work it all the way down, we can do that with this number. So, like I said, 441, it looks like, a prime number at first glance. But what we're going to do is we're going to take it by 3. We're going to divide this number by 3. So we're going to get 3, the square root of 3. And then 441 divided by 3 is 147. Now, 147, I can do a prettier 147 than that. It's a little late. So 147 by itself looks kind of prime by itself. What you can do with this number, but it's not prime. It's not prime. So what we're going to do is we're going to take another 3 out of there. Honestly, if you don't just know these numbers off the top of your head, You get to do trial and error. Now, thankfully, we know it's not a multiple of 5, but this number is a multiple of 7 and 3. So, like I said, this one just happens to work out to be pretty even like that. So I'm going to take another 3 out. And then 147 divided by 3 is the square root of 49, which we know equals 7. Okay? So we have 2 and we have 7. And we have 2 square root of 3. So the square root of a number times the square root of the number is that actual number. So we're going to cross both of these out and get 3. Okay? So then we're going to multiply 7 times 3 times 12. And our answer is 42. So all in all, the square root of 1,764 is 42. But our answer is not all the way complete yet. After we get this 42, we have to multiply it by this 12. This 12 on the outside. So our final answer is 504. 504 is our final answer. The next question, we have 3 radical 900. It's not as difficult. We know that there's a perfect square of 100, and we know 100 times 9 will get us 900. We don't have to dissect it that far. We can just do square root of 100, square root of 9. We get 10, we get 3. 3 times 10 times 3 is 90. There's our answer. The next 2 questions, like I said, we're going to do a little bit of digging to find the answer. It's not so clear cut. Okay, so our next question is 7 with the square root of 2,535. Okay? Now, without any prior knowledge, this number, even myself, I did not know off the top of my head by looking at it what the perfect square in it was. But I knew that there had to be a perfect square in there, so I divided it by 5. I took a 5 out. And I still was not sure. So I divided it by 5, and on the other side, I got 507. And even from here, I'm pretty sure this was not my answer. I knew there to be some perfect square in 507. I know 507 itself is not a perfect square, but there had to be a perfect square in this question, unless they wouldn't have given me the problem. We know 5 can be taken down in. So I don't know when to the first thing I knew what to do. I knew I could divide it by 3 as my first guess to give me a partial answer. So I divided it by 3, so I got the square root of 3 out. And then 507 divided by 3 is the square root of 169. So I'm sorry, 507 divided by 3 is 169. Now, at this point, you could just put it in your calculator to figure out what the square root of 169 is. I'll just let you know, now it is 13 times 13. I guess if you could just go through the perfect squares, it can't be 3, it can't be 7, but just to let you know, the square root of 169 is 13. So that was our answer. So here's where I'm at. I have this 7 times this 13 that can be multiplied. And then I have this radical 3 and this radical 5, these 2 square roots that can be multiplied together. So my final answer is 91 radical 15. the final answer. Then we have 11 radical 1,215. Without any prior knowledge, we know that there's at least a 5 in there because the number ends with 5. So we can go ahead and take this radical 5 out. Then we divide 1,215 by 5. Our answer is 243. I did a little different on my assignment, but it'll be a lot easier if you just go by 5, because that's the easiest recognizable number. Okay, so now we have 243. We know there has to be a perfect square in there, but we don't know what it is. Our best bet, and thankfully we can do this, is start by the 3, dividing it by 3, and see what we can get. So we divide it by 3, and then we're left with 81. We know 81 is a perfect square. It's 9 times 9. So we're going to take 9 out of this, multiply it by this, 11 times 9, and then this radical 3 times 15. Our answer is 99 radical 15. That's our answer. Then our last question for this assignment is 2 radical 200. Okay, so right now I can take a radical. Well, we know that there's 100 and then 2. So 100 and then radical 2. We know we can't do anything with there. We know radical 100, the square root of 100 is 10. 10 times 2 is 20. Radical 2. There's our answer. So that's the end of this assignment, and I will try my best to have the other one up in a prompt and timely manner.